Hello everybody. Today we talk about soft landing. What is soft landing? Soft landing is the unit is come down slowly and land on the ground without impact. Okay, so that's a soft landing. Hard landing, of course, it's crash, right? And this soft landing is harder when gravity is large, like Earth. No nation can do soft landing. NASA typically they bring the satellite down to ocean. They dip into the ocean and they pick it up from ocean. The China, they always go to the desert, and when this parachute unit come down several feet before it's hit the ground, they have an explosive, and the explosive is detonated. So this speed, landing speed, is the explosive is going to push up and suddenly reduce this landing speed. It's like a hitting a brake. So you see when the capsule almost touching ground, you always see the kind of firing. So they have a detonation to reduce the shock of landing. You see SpaceX, they soft land, so they should be able to soft land on Earth. Well, actually this is the first stage of the rocket, and when you go rocket, first stage of the rocket is at this height, so coming down it's not that much speed, so that's why you can do soft landing like this. Okay, and second stage go up even higher, third stage go to the moon, the second stage bring the orbit to SpaceX, second stage bring it to the lower orbit, but actually the rocket has to be much bigger, so second stage bring it to even higher orbit, and from there you go to the moon. When something comes down from higher orbit, the Earth's gravity increases speed much bigger than this, so soft landing is almost impossible, and no nation can do, no company can do soft landing. You can do soft landing only the first stage of the small rocket, which is not that high and it's coming down, the speed is limited. Okay, so when the capsule come back from moon, it's come back from high orbit all the way, very high speed, and even you reduce the speed by parachute, still it's hard to do. So NASA is always use the ocean. They just dip into the ocean, plunge into the ocean and pick it up later. Okay, so soft landing is almost impossible when you come back from the moon. Either you use Chinese method in the desert, the slow down by parachute and use explosive to suddenly reduce the speed. It's like hitting brake and land, or use NASA's method, just dip into the ocean, then the Navy ship pick it up later. On the moon, the gravity is 1/6, so it's relatively easy to hovering around. When it's come down, the two things you need: the enough engine power and electronics to keep this posture, the orientation. Okay, so far we know India failed twice in the soft landing. The first one, from moon orbit, it started coming down, and they had a good communication until about 200-meter high, and the communication just dropped and couldn't communicate anymore. That means it's crash landing and it's broken. The second time, India said they had a communication until all the way down to the ground level. This is about 200-meter high. It's lost communication. When it's touched the ground, it's a lost communication again. That means it's could be hard landing, and some of equipment broken. Indian couldn't produce this usually selfie of landers. They couldn't produce the selfie at all. Israel went to the moon orbit, and they said they're gonna go down for landing, and immediately when it's go down, it's lost communication, so it's failed. Japan, first time, same thing. When from orbit it start going down, then lost the communication. Second time, Japan finally landed, but there is a problem. If you look at Japanese landing unit, it's like engine is up this way, so it's kind of upside down looking. Actually, Japan's intention was hovering around until it's moving sideways until it spot the correct place to land, then move to sideways, okay, and land like this. This is the correct posture, but it's landed this way. But the good things about Japan, they did the good things is they dropped the camera unit, and the camera unit took the selfie, so it clearly shows the selfie picture came back to the earth. It's landed, but it's the wrong posture, and they worry about deployment of solar cell because battery run out, then lose the communication. But seemed like they could deploy the solar cell and collected the electricity and communicate. But after that, it's past one moon night, and moon night is about half month, because every month it's become day and night. The 1 month is 1 night 1 day, so about 15 days moon night. Is very cold, and tests see if all electronics survive. Inside has some battery unit to keep the electronics warmer, and when they come, moon day come, the electronics wake up and start communicating, kind of things. Japan confirmed it did that. After 1 night they could communicate, but there's no more details about what communicate. Oh yeah, one more is they took the camera shot from this position, camera shot of the ground, and sent back to Earth. So Japan is successful. This successful, but say 3/4, because position is completely wrong, right? And right after this, the NASA funded the private company, send it, and the same thing, it start going down, and when it hit the ground, it's lost communication. So NASA couldn't make it work. The India probably hard landing. In Japan, it's not hard landing, it's soft landing, but it's kind of landing on the wrong posture. So how China does? China has an engine, and rover is sitting on top. And usually when it's come down to about 20-meter high, China's lander move sideways and check, see any big rock or slope kind of things, and find this is automatically done, this pattern recognitions AI. It's find flat nice place and it's land, and there is a ladder extended for rover to come down. So rover roll out and take a selfie of the lander, and lander take the selfie of rover. And typically communication from rover is done through lander, and the lander to China always keep the satellite in the orbit, and this orbit, the satellite has a big antenna, parabol antenna, and using that to communicate to the Earth. Because from ground, the limited size antenna directly communicating Earth will be very difficult. So this has the tracking antenna. It's track the satellite position. It's communicate with satellite, and rover communicate with this one, the lander, and lander act like a relay of the rover's signal to the satellite, and satellite going around the moon communicate with Earth. And the communication technology is very important, because you try to communicate from the ground directly. Actually, we don't know what's happened to India, the hard landing, but see, they landed almost like South Pole, and here they have antenna and try to communicate. This could be a problem. Communication may not be able to do it with a little antenna on the lander here, because there is a ground effect. It's almost close to South Pole they landed, and proper way maybe let the satellite relay. So proper way is not like, bring the lander only and let the soft lander and communicate with lander directly. The proper way is probably you bring with this carrier, and lander unit is separated and landed, but this carrier is going to still keep going around the moon and act like relay satellite from the ground. The number one antenna is much bigger, and number two, the antenna direction is more flexible, more clearance in orbit. So for this reason, it can be much easier to communicate with Earth. So I think it's the best way is to have carrier that carry this lander unit all the way from Earth to the Moon, and this one go to the land, and the remaining unit stay in the Moon orbit and act like a signal relay with a large antenna. It's probably engineering that makes sense. Okay, Mars has about 1/3 of Earth's gravity, so soft landing on Mars become much harder. And because it's much harder, the NASA's first soft landing is they put the rover inside a big balloon. So what's happened is they have a carrier of the rover, right? Carrier has a rover here, unit come from Earth, and the rover start descending and inflate this balloon around. And after the acceleration by parachute, this Mars has a very thin air, like 1%. At least you can decrease the speed, and this has a huge balloon inside that has a rover. They drop it on the ground, so this is gonna roll down, and if you make this side heavier than other side, the hope is to put the right orientation. And after it's roaring all the way, it stop at the right orientation and release the gas from the balloon, so the rover is going to be there to start exploration. So this is actually NASA claim they did it. I highly doubt it. What if it's hit the rock? It's not right orientation, and there is a big rock, and if you release the gas, then rover is this position and cannot even move, or maybe upside down. This is a gamble, and you spend all the money and effort, send it to Mars, and just like a rolling dice, hopefully you see lucky 7. Well, actually dice doesn't have a 7, so maybe dice 1 come up, then rover can survive and start moving. And NASA claim it was successful, the first rover on the Moon, and a bunch of photo from the Mars was like the photo from Devon Island in Canada. So I don't know, a lot of skeptical people around the way they did. This is because soft landing is much harder, and the 1/3 gravity. Okay, So China adopted the same method as the moon, just use more powerful engine to slide parallel, go and find the right place to land, and they land. And use the same method as the moon, rover roll down and start exploring. Okay, so this landing method make more sense. This is like a casino method. This you hope it stop at the right position, then also rover doesn't get damaged because of the cushion of the balloon. But this falling speed is very fast. I will guess those balloons gonna pop when it hit the ground, but they said it didn't. Okay, because you cannot decrease the speed that much with 1% atmosphere. This parachute has very limited role in reducing speed from orbit to the ground. So it's gonna roll really hard and roll around. It stops somewhere, just right place, the right orientation. Then they claim it did successful, and the rover's picture is kind of skeptical pictures. So I don't know if it's just an entertainment story or the real landing method. So second time, everybody is skeptical. NASA changed the second time landing method. Second time, I don't know why, but NASA said, okay, this come down from orbit and engine is this way, blowing kind of both sides, and they have rover, and if you land here it may crush the rover, so they use the rope lower the rover down to the ground. Okay, so what happened to this unit? This unit stay until rover touch down the ground, then cut the wire and fly away somewhere. And where? Fly away to where? Well, there's no details. And they claim this was successful too, this method of landing. China insists on same method used in moon, and they said they just made this engine bigger so it can sustain this one third of gravity. It's not as heavy as Earth's gravity, so it can sustain and move around to find the right place to land and bring the rover down by ladder. But this is NASA's method. They claim this is the way they lower the rover down by the wire, and when it's touched the ground, this is like engine is going this direction, so it doesn't, the hot gas doesn't hit this rover. And that's the way they did this wire coming down. I don't know what kind of engineer they use, but this is not really engineering idea of soft landing. I mean, it's really strange, weird idea for putting rover. And this one fly away where? Let's fly away somewhere in the crash. This unit is just totally wasted. And another thing is this rover has little antenna. I don't see even the parabola antenna on the rover, but they claim it's communicate with Earth from the ground directly. The China always go through this lander, and the lander communicate with satellite on the orbit. This satellite has a large antenna communicate with Earth. So this process is exactly the same as the moon. The NASA knows soft landing on Mars is not easy, so use this balloon method and revise into this method second time. And I'm sure they are going to revise it again because a lot of skeptics about this method of landing, so they are going to change the story again. So that's the story about landing. Soft landing is not easy, and you know, this has whole set of new technology you need to develop. It's not just X-Space rocket that goes to the low orbit. It has to go high orbit and fly all the way to the moon. And this soft landing technology is how to maneuver this heavy stuff by the engine and keep this posture. Don't do like Japan, right? It's going to land on the sideways. It's upside down. In order to avoid that, you need to have a very good electronics to keep this posture and moving parallel to the ground until it's find it's a self pattern recognition of the ground to find the right place to land. There's a little bit of AI here, and once it's landed, then rover come down. This kind of method is very reasonable, and it's used in moons. It works. We haven't seen NASA send a rover into the moon. What kind of method they use, we're not sure, but probably no lander. It's just drop the rover directly onto the moon kind of method they are thinking about. But that may not be a good idea if human go. They need to have a unit on the orbit. Even Apollo story, the one guy was in the orbit and two guys descended to land. That's probably the right approach. You cannot just put the three guys on the moon, right? Okay, so that's all for today. I hope you see this whole set of new technology has to be developed just to soft land on the planet, moon or planet. And without this set of technology developed, you cannot just claim you can go to moon or Mars with only rocket you have. There are new set of technology required for landing. It's not just rocket. Okay, so I hope this video is interesting enough. Please subscribe and give likes if you like, and wait for the next story.